All right, we're moving on with Chapter 8 today. In Lesson 8.3 on Tuesday, we learned about factoring trinomials that had a coefficient of 1. Today we're going to be talking about factoring trinomials with a coefficient other than 1. So the standard form here for these trinomials is going to be ax squared plus bx plus c. As you notice, we've talked a couple times about it, but anytime you're factoring these, you always want them to be in descending order in this standard form. So with your x squared term first, then your b times x, or your constant times x, plus just your constant of the number without a variable. So there's a couple different ways that we're going to learn how to factor these today. The first one, I'm going to take you through a step-by-step process here. When we have a coefficient besides 1 as our a value, we can use the following pattern. So again, coefficient other than 1 as our a value, so with our x squared. First thing we're going to do is find two numbers that have the same product. My dot got moved over. That have the same product of a times c, and that have a sum of b. So I got into this a little bit in the last lesson, where on our diamond method we did a times c in the top and b in the bottom. So again, we need to find two numbers that have the same product of a times c and that have a sum of b. Then we're going to break our b value into those two new values and then factor by grouping. So this is going to be the first method that we're going to learn. The second method that I'm going to go over with you guys will not include grouping, but it'll include that diamond method that we talked about last time. So an example of following these steps, if we have the trinomial 6x squared plus 17x plus 5, that 5 should not have an x with it, I'm sorry. So 6x squared plus 17x plus 5. What we're going to do, again, is we need to find two numbers that multiply to a times c, which in this case is 30, and that add to our b value, which is 17. In this case, that's going to be 2 and 15. They multiply to 30 and add to 17. So then we're breaking that b value into two separate values now, which are going to be those two numbers we just came up with. So instead of 6x squared plus 17x, we're going to have 6x squared plus 2x plus 15x plus 5. Doesn't matter which order you have those 2x and 15x in. When we factor by grouping, you'll get the same answer either way. But then once we've got it into those four terms, we're going to group the first two and the third and fourth. We can factor a 2x out of this first group, and we're left with 3x plus 1. We can factor a 5 out of the second group, and we're left with 3x plus 1. So then if you remember factoring by grouping, the first binomial is going to be whatever is outside the parentheses, so 2x plus 5. The second binomial is whatever is inside the parentheses, which is 3x plus 1. So that's one method. Now I'm going to show you the diamond, or we can call it the X method. So using this same trinomial right here, if we draw in our x, again in the top we want a times c, in the bottom we want b. So a times c, 6 times 5, would give us 30. B is 17. So now we're going to put our two numbers that we would come up with, which we know are 15 and 2. And then what we're going to do is take whatever that first term is, which in this case it's 6x squared. We're going to get rid of the squared, and we're going to put a 6x in front of each of those two numbers that we just came up with. So we have 6x plus 15 and 6x plus 2. Then we want to see if we can factor anything out of those two terms. So here we can take out a 3, and we're left with 2x plus 5. Here we can take a 2, and we're left with 3x plus 1. Then we're going to get rid of those numbers that we factored out, and we have our answer of our two binomials, 2x plus 5 and 3x plus 1. Same answer we came up with right there. So again, just like I talk about a lot, two different methods of doing it, coming up with the same answer. As we go through some different examples here, I will walk through some of them doing it the grouping method and some of them doing it the diamond method. When you get to your homework, it's up to you. Whichever one makes more sense for you, you can go ahead and do. So on our next slide, we've got a few examples we're going to go over together. First one, 7x squared plus 29x plus 24. So I'm going to go ahead for this one and do the grouping method. Now, the first thing you always want to see before you factor using either the grouping or the diamond method is see, is there a greatest common factor that I can factor out of the entire trinomial? In this one, there's no variable we can factor out of all three terms. There's also no number that we can factor out of all three terms. So we're going to go ahead and start where we are right here. So again, with this method, I'm going to break up that b value into two different terms. And it needs to be two numbers that multiply to a times c, which in this case is 28, and that add to 29. In this case, that's going to be 28 and 1. So instead of 29x, I'm going to have 28x plus 1x plus my 4 at the end. Now I'm going to break this up into two groups and factor. So this first one, 7x squared plus 28x, I can take a 7x out of that group, and I'm left with x plus 4. My second one, 1x plus 4, the only thing I can factor out of that is a 1, and I'm left with x plus 4. Again, with grouping, you always want to make sure whatever is in the parentheses is the same. So then I'm going to have my two binomials. First one is everything outside the parentheses, 7x plus 1. Second one will be x plus 4. And there's our answer right there. So then the next one I'll go ahead and do using the x method. So for this one, again, same thing. We always want to start with, is there any common factor that we can factor out of this before we get started? In this case, there is not. So using our x method, in the top, we have a times z, which is going to be 280. In the bottom, we have our b value, which is negative 43. So since our b value is negative and our c is positive, we know that our two numbers that we come up with are both going to be negative numbers because they have to multiply to a positive and add to a negative. Now if we go through, 280 is kind of a big number, so this is one where you might have to use a little bit of guessing and checking. So we know we can do 1 times 280, 2 times 140. I wrote a few of these down before I started here. 4 times 70. If we think of these, well actually, they're all going to be negative. If we think of these, so far none of those added together are going to add up to negative 43. We could do negative 5 times negative 56. We're getting closer. That'll give us negative 61. We could do negative 7 times negative 40. Those added together would give us negative 47. We could do negative 8 and negative 35. Added together give us negative 43. Multiplied give us positive 280. So those will be our two numbers, negative 8 and negative 35. Then again, I want to look at my first term, which is 10x squared. So I'm going to put a 10x in front of each of those. So I've got 10x minus 8 and 10x minus 35. Now, I need to see if I can factor these down any further. If I can, so here 10x minus 8, I could take a 2 out, which leaves me with 5x minus 4. 10x minus 35, I can take a 5 out, which leaves me with 2x minus 7. Then again, whatever you factor out here, if they are different numbers, you can get rid of them. And we end up with our factored form of 5x minus 4 times 2x minus 7. Now just quickly, if I had done this one the grouping method, I would have come up with those same two numbers that multiply to 280 and add to negative 43. The two numbers were negative 8 and negative 35. So I would have split this into 10x squared minus 8x minus 35x plus 28. Then I would have grouped here. I can take a 2x out of my first group and I'm left with 5x minus 4. My second group, I can take out a negative 7 and I'm left with 5x minus 4. And then put my terms together. I've got 2x minus 7 times 5x minus 4. So same answer there, and there, two different methods of doing it. Now this last one, if we take a look at this, again, we always want to see if there's a common factor we can take out first. 3, 24, and 45 do all have a common factor. We can go ahead and factor out a 3 before we even get started. When we factor out our 3, it gives us x squared plus 8x plus, 45 divided by 3 would give us 15. So now we've got it broken down to a trinomial with smaller numbers. This goes back to Tuesday's lesson now of trinomials with a coefficient of 1. So we're going to go ahead and factor that down. B and C are both positive, so we know they're both going to start with x plus. Then we need two numbers that multiply to 15 and add to 8. That will be 5 and 3. And then since we factored that 3 out in the beginning, we would need to factor it out, or we would need to include it in our final answer as well. Now, if you were doing this one using the x method, and you didn't factor out that 3 to start with, you just go ahead and do a times c, which would be 3 times 45, which gives us 135. Then our b value of 24. We would need two numbers that multiply to 135 and add to 24. Those two numbers would be 15 and 9. And then we would need to put a 3x in front of each one. So 3x plus 15 and 3x plus 9. Here we can factor a 3 out, which leaves us with x plus 5. This side we can factor a 3 out, which leaves us with x plus 3. So this is where, if you end up with the same number that you factored out of both, you need to include that in your factored form of your answer. So we would have 3 times x plus 5 times x plus 3. So next is determining whether a polynomial is prime. What it means for a polynomial to be prime is, can we factor it out using the methods that we have learned of factoring? Now, every polynomial can be factored using the quadratic formula. We haven't gotten to that yet, so for today we're just going to be worrying about the methods that we have learned for factoring, And if it can't be factored that way, that means that it is a prime polynomial. So for this first one, all you really have to do to determine whether or not these are prime is draw in your x, a times c in the top, b in the bottom. So a times c, 2 times -2 is -4, b is 5. Can we come up with two numbers that multiply to -4 and add to +5? Now we know that one has to be negative and one has to be positive. We know that the larger number has to be positive. So we could have 4 times -1 gives us -4, but that would add to 3. So in this case, we can't come up with two numbers that multiply to -4 and add to 5. So that means we would say, yes, this is a prime polynomial. And that's all you have to do there. The second one, if we draw in our x, a times c in this case would be 2 times -5, so -10. B would be 3. So two numbers that multiply to -10, add to 3. We know it's a negative and a positive, and that the positive will be larger because they add to a positive number. Here we could say 5 and -2 multiply to -10 and add to 3. So is this a prime polynomial? No, because we can come up with those two values. It can be factored. Again, if all it's doing is asking you to determine whether it is prime, you don't have to factor it. You just have to say yes or no. And then the last one here, again, we start with our x. A times c would be 28. B would be -1. Two numbers that multiply to 28 and add to -1, meaning they're both going to be negative numbers. In this case, there are no two negative numbers that multiply to 28 and add to -1. So we would say, yes, this is a prime polynomial. And on those, again, your answer is just yes or no. So on that last slide, we talked about how to factor the polynomials, come up with those factors. Last time we talked about factoring, we learned how to factor first, then we took it a step further and solved an equation by factoring. So we're going to do the same thing now. We want to solve the equation by factoring. Just like we did on Tuesday, in order to solve by factoring, first we have to have our trinomial set equal to 0. So that means anything on the right side of the equals sign, we need to move over to the left. In this case, I'm going to do two steps at once here. I'm going to subtract 4 from both sides, and I'm going to add 3a to both sides. So everything on this side cancels. On the left, I have 8a squared minus 6a minus 9 equals 0. So now I'm going to go ahead and factor this so I can solve. I'm going to do this one with the grouping method. So I have 8a squared. I need two numbers that multiply to -72 and that add to -6. Now in this case, since we know that one needs to be positive and one needs to be negative, we can still draw in the x to help us. Let's see, multiply to -72, add to -6. So here I'm actually combining my x method and my grouping method. So those two numbers that I need to come up with need to multiply to -72 and add to -6. Those two numbers are going to be -12 and 6. So this is actually, I would probably go with this method as you go through on your homework of combining our x and our grouping together, using the x method to help you come up with those two numbers that you need for the grouping. So we need to split that -6a into -12 and 6. So I'm going to go ahead here and say 8a squared minus 12a plus 6a minus 9 equals 0. Then I'm going to group my terms. 8a squared minus 12a, I can go ahead and take a 4a out of that, and I'm left with 2a minus 3. Then my second one, 6a minus 9, I can take a 3 out of that, and I'm left with 2a minus 3. Then again, everything outside the parentheses together, so 4a plus 3 is one binomial. 2a minus 3 is another binomial. So now that I've got it factored and set equal to 0, then my last step is just to set each of these binomials equal to 0 and solve for a. So on the 4a plus 3, I would subtract 3, which gives me 4a equals negative 3. Divide by 4, and I would get a equals negative 3/4. On the second one, I'm going to add 3 to both sides, so 2a equals 3. Divide by 2, and I would get a equals 3/2. So negative 3/4 and 3/2 would be our two solutions to the equation that we started with, which means that you could plug either of those values in for a, and you would get the right answer. So let's do one more of these. I'm going to do this one the same way, where I'm kind of going to work the grouping and the x method together. So the first thing I want to do, this should be set equal to 0. The first thing I want to do is figure out, is there a common factor that I can take out of every term here? In this case, I can take 2 out, and that would leave me with x squared minus 15x plus 44 equals 0. So now I've got this down to a trinomial with smaller numbers that are easier to work with. So my a times c, 1 times 44, gives me 44. My b value is negative 15. So two numbers, they're both going to be negative numbers because they multiply to a positive 44. They add to a negative 15. My two numbers are going to be negative 11 and negative 4. So now I'm going to have 2 times x minus, x minus 11 times x minus 4 equals 0. Then I just set each term equal to 0. So I'm going to say 2 equals 0, x minus 11 equals 0, and x minus 4 equals 0. 2 equals 0 is not true, so we're going to ignore that one. We add 11, it gives us x equals 11. Add 4 here, we get x equals 4. So our two solutions would be 11 and 4. Now, as you move on in math, especially when you get into Algebra 2, this will become more true because you'll work with polynomials that have a higher degree than 2. But if your polynomial starts with an x squared, if a squared is your highest power, that means you need to come up with two solutions to the polynomial, which in this case, again, were 11 and 4. There's your homework for the lesson. Again, I know I've said it on every video, but I'm going to keep saying it. Please reach out as you have questions. A few of you have been awesome about that, whether it's emailing me to set up a Zoom time or texting me and I can shoot you a quick video about a question. But always, 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 please feel free to reach out if you have any questions at all. Thank you.